All right, hello everybody. My name is Andrew Smith. I'm going to be doing a presentation on how to get deployed through Elastic Beanstalk, which is the Amazon Web Services equivalent to Heroku. So I've gone through this a couple of times. I'm going to be doing this live. Hopefully it works out. And yeah, I'll be doing a couple of edits along the way to get rid of loading times and things like that. So without further ado, let's go ahead and get started. I'm going to be using this repo that was started by Kay Winery. It's called To Do MVC++. So it's a really nice repo out there that's built off of Vue.js and has a PostgreSQL backend. It was based off of work done for this presentation on front-end masters called Zero to Production with Node.js. And yeah, it's a great starting point, so I decided to work with that as a way to explore setting up Elastic Beanstalk and also to set up Travis to be able to make my deployments through continuous integration. So we'll start by downloading this. Go ahead and grab the URL. And open that up. And the README has a lot of the information that we need for it. There's a bunch of stuff around installing various dependencies so that we can get both the AWS CLI and the Elastic Beanstalk CLI. So we have to do some things to install Python and upgrade pip, and then eventually install the AWS CLI, and then we get the Elastic Beanstalk CLI through pip here, and then we have to add Python packages to the load path. So that's this part here where we add the version. We get our version here and then we put in the version there. So if it was like Python 3, then you'd put 3 there. If it's 2.7 in my case, then it's 2.7. But I'm going to skip over that part because that's pretty straightforward, and I'm going to go right into the AWS part of it. So here we're going to start by creating an IAM user. So IAM stands for Identity Access Management. And it's essentially the way for you to manage users in your AWS account. So you have a AWS account with my account at gmail.com, and you have a password associated with that. That's called your root credentials. So that gives you access to everything. But for a lot of companies and a lot of users, you have a lot of different sort of sub-users within that root credentials. So like you have my email at company.com, and that's like the company's AWS account, and it manages all of its resources. And so underneath that, you then create users so that people can access those credentials and be able to create resources under this account. So it's essentially a way of controlling access to your credentials, and it's extremely powerful. It's also necessary to create an IAM user if you want to have an API like access keys, which is what will be necessary for using Elastic Beanstalk. So we're going to go ahead and get started with that. So we go to console.aws.amazon.com. We'll go ahead and open IAM. We'll create a user. We'll call it Andrew. And I want to make sure that I give myself programmatic access, so that gives me the access key ID and the secret access key. And for right now, I don't need to enable a password. I could if I wanted to, but for right now, I'm not worried about it. I'm not going to get rid of my root credentials just yet. So if you wanted to, like if you wanted to create a user that had admin privileges and then get rid of your root credentials, then you would want to go through this. Anyway, so moving on to permissions. So here we need to give permissions to the user, and there's a variety of ways to do it. There's one where you can attach a policy directly, so that essentially says like, okay, this user has these accesses, or you can copy permissions. But the most common one is to just add them to a group, and the group has permissions associated with it. So it's a convenient way of controlling permissions. So like you could have a group called devs and a group called DevOps and a group called database administrators, and they all might have different privileges based upon what they need to access. So going along with the principle of least privilege, like this is a good way of managing all of that for you. For my case, I'm not worried about it because I'm just my single user right now. So I'm going to go ahead and create a group and just give them admin access. So I'm going to call my group admin, and I'm going to attach the administrator access policy. So this provides full access to everything. If, however, I wanted to be more specific and I wanted to say, like, this is my DB administrator, then I could instead search for something like DynamoDB, and I'd give them DynamoDB full access and also RDS full access, something like that. So that's another way to go about it. I'm going to go just undo this and just call it admin. Go ahead and create the group. Great, so now we have a group. We've attached, we're choosing them as the group to add. Go ahead and review, create the user. So I'm going to copy my secret access key and my access key. And there's a variety of ways to store your credentials. You could just save it as a CSV. I like to actually use the AWS CLI to store it. So if we go to the iTerm, and we type in AWS, let's see what it is. AWS configure -- profile and then the name. So I'm going to say AWS configure -- profile. And then I'm going to call it Elastic Beanstalk demo, or I'm just going to say Andrew. Yeah, let's just call it that. I'm going to paste in my access key and my secret access key. And then I'm going to say US West 2 is my region, that's Oregon, because Oregon's the best. And then we're done. So now we have it stored, and then there's this other part where we can reference this user. So if you're curious, all of this gets stored inside of a folder. So we have a folder in our home directory called AWS, and it has these two files, config and credentials, and that stores the information for you there. So you can always go into AWS and manipulate it there if you want to. Okay, so we've got that done. Now we can go ahead and, what's the next step? We can go ahead and initialize the Elastic Beanstalk configuration for the project. So we have our project downloaded, and what we're going to do is essentially tell Elastic Beanstalk to be prepared to make deployments on this project. And so it sort of provides a special, like a configuration. And it creates some files that you don't end up checking into your repo. So this is stuff that you store locally. So we can say ebinit, so it's this command here, ebinit -- profile, and then the profile that you just provided. So -- profile, oops, Andrew. And I'm going to say my region is in US West 2. And I'm going to call it to do MVC++. Sure, that's great. That's my application name. It is using Node.js, and I don't want to use code commit. For those of you who are curious, code commit is sort of like GitHub, except it allows you to have a little bit more control over like how and where your code is stored. So for most people, GitHub is perfectly good, but there are people who need to use something like code commit. And for right now, so it's asking if we want to set up SSH for our instances. So Elastic Beanstalk, as part of what it's going to do, is create EC2 instances for us. And we could set it up so that we could SSH into those EC2 instances to change stuff around. In our case, we're not worried about it for right now. So we're just going to say, no, we don't care. And then we're done. From here, you can see that it's created this .elasticbeanstalk config file. And as you can see here, it's using this profile, Andrew. So this is why you don't store this in your GitHub repo, or in your repo, because this will be particular to your user. Yeah. So moving on, we're going to then actually create the environment. So we have an application, and then inside of our application, we have different environments. And those environments could be, different stages of development. So you could have dev and test and prod, or you could have different environments that represent different regions. So you could have, prod-Oregon and prod-Ireland and prod-London. In our case, we're only going to create the one environment and we're going to not worry about anything else. But Elastic Beanstalk provides a lot of useful uh, features for you to be able to manage your environments, and that's a more advanced DevOps situation. So we're going to go ahead and do this next line, which is eb create. And by default, it appends this -dev for us. I like to test in prod, so I live dangerously, so I'm going to just create straight to prod. And then this CNAME prefix is essentially like Elastic Beanstalk will create a URL for you to hit that has this name somewhere in it, and it'll have a bunch of other information on it as well. I'm going to just say that this is a fine name to have, so we'll just go with the default there. You can choose which kind of load balancer type you want. Classic is perfectly good. And then it's going to go ahead and create a bunch of stuff for us. Okay, so the next part is that we're going to go ahead and create a database inside of our AWS account so that we can store our data. To do that, we're going to go back to the console, and we're going to look up RDS. So RDS stands for Relational Database Service, which is AWS's version of a relational database. So that would be SQL. DynamoDB would be the NoSQL equivalent. So we're going to go ahead and open RDS, and then we're going to create an instance. So we're going to get started. And we're going to choose PostgreSQL. In our case, since I'm just doing this for demonstration purposes, I'm going to use DevTest. But in the real world, you'd probably want something like a production grade PostgreSQL, which allows for better IOPS storage, so it's better performance, and also that it can deploy to multiple availability zones within your region. I'm only interested in looking at the free tier here, so that's going to limit some of our options. The database instance identifier, this is the name that is going to appear in your list of DB instances. So I'm going to call this to do MVC++ database. And for the master username and password, this is a way to get into your DB instance. We're going to set this up to not be publicly accessible to the internet. So it's going to be fine to not have a super secret password and username. In our case, we're just going to call it AWS user and password. So the VPC is a kind of a complex concept, but you can use the default there. That's good enough. And then we're going to set it to be not publicly accessible. We don't care about which availability zone it's in. And as far as the security group goes, I'll explain what that is. So a security group is essentially a way to organize the connections that you have, the resources that you have, and what permissions they have to talk to one another. So for instance, the EC2 instances that are getting created by Elastic Beanstalk, they're going to belong to a security group. And we can say what sorts of permissions that security group has in terms of how can those EC2 instances be talked to, both inbound and outbound. What kind of information can they give, and what kind of information can they receive, or what ports can they receive information over. In our case, we have our EC2 instances, which are going to be receiving traffic from our load balancer. And I'll go ahead and actually show that here. So I'll just full screen that. So we're going to have our load balancer, which gets set up by Elastic Beanstalk, and that's sending traffic over to our EC2 instances. So this security group is going to have to allow traffic over the internet from the Elastic Beanstalk to be able to receive it. By contrast, we don't want to allow our database to have traffic over the internet. So we're going to put that in a separate security group and tell it that it can only receive traffic from these two security from this security group that contains my EC2 instances over the port that PostgreSQL uses to talk. So we're going to just go ahead and create a new security group with the database name that is expected from our app is called to-dos. We're going to use the standard default port, which is 5432 for Postgres. And then all of the other options you can configure, but for right now they don't really matter. And then that's going to go ahead and create our DB instance. So I'm going to open that up, and then we're going to wait a minute, or a lot of minutes. All right, so now we have our database instance, and we also have the Elastic Beanstalk environment finished creating. So we're going to connect those two pieces together. So we can go to the endpoint and pick that up. So we're going to go ahead and copy that. And then I'm going to go over to, let's see, just make sure this is the correct next step. That. Yep, we're going to configure the Elastic Beanstalk environment. So here's our application. It's to do MVC++. And right now we have our prod environment, which is degraded because it's not been correctly configured yet. So here we're going to go over to configuration and choose software configuration. This allows us to set up some basic pieces about Elastic Beanstalk, such as like which proxy server we use and which node version we want to use, things like that. What we care about are a couple different pieces. One is that we want to set up static files to be served up by Nginx for our application so that we can serve up our JavaScript and CSS files. This is something that eventually you'd want to set up CloudFront to do, but for right now we're just going to serve it up from our web app. In our case, we expect for this application, it's expected that the web browser will hit a path of, /static. So we're going to put that in here. So that's like if you go to mywebapp.com/static/app.js, then this is the virtual path there. And we're going to route it to a folder called public, which is what we will build inside of our app. So we have that, and then we're going to give it a couple of environment properties. The obvious one is that we want to set the node env to production. And we want to set the npm config, I believe it's npm config production. Yes, npm config production. Set that to true. So that means that we only download the dependencies rather than also the dev dependencies. So it makes our builds look just slightly faster. And then we're also going to need to provide a RDS connection string. So inside of this app, the way that it's set up, inside of config for production, we have our database URL, and that's going to be based upon the environment variable set called RDS connection URL here. So we're going to put that in here. RDS connection URL. And we're going to use that URL that we copied from Postgres, from RDS. But we need to create a PostgreSQL connection string. So the way to do that is to type in Postgres : / and then your username and password and then the string. So our username is AWS user. Our password is password, and that's going to be and then the rest here is the connection, the URL, and then the database name. So this part here I'm going to paste in, and I'm going to delete the port number because we don't need that. So this is the RDS connection URL string you see here for to-do MVC++ database. And then the database name is to-dos. I'm going to hit apply. And that's going to set that up. So that's piece number one. Piece number two is that we want to set up our RDS instance to be able to receive traffic from our EC2 instances. So we're going to open up the console. We're going to go to EC2. We're going to take a look at our security groups. So here we can see that we have a few new security groups from last time. So there's this security group for the EC2 instances created by Elastic Beanstalk, as well as a security group for the load balancer. And as you can see here, like for the load balancer, for instance, it receives traffic across all of the internet and sends traffic across the whole internet. And for the EC2 instances, we're going to allow traffic to go out across all ports, but we're only going to allow receiving traffic across port 80, so that's HTTP, from our Elastic Beanstalk. So we won't be able to hit these EC2 instances from the general internet. You have to access it from the load balancer, which is pretty cool. This sort of helps prevent, it reduces the attack vectors, or the surface area of our attack. And then we also have a new security group for our RDS instance. So right now what we're going to do is we're going to tell the security group that it can receive traffic we're going to tell the RDS instance that we're going to allow receiving traffic from port 5432 from our EC2 instances. So we're going to click on this guy, we're going to choose inbound, and then we're going to edit it. And I'm not exactly sure what this number is here for. I'm guessing that it's like the actual RDS instance, but we're also going to add a rule to allow PostgreSQL over 5432 from our EC2 instance security group. So that's this guy here. So that's SG5BEA. So this one. And we're going to hit save. And that should do it. So this is currently updating our environment still. And just to be extra safe, we're going to go ahead and reload this. Just restart the app servers. Okay, I'm going to go ahead and check on what needs to happen next. So we've configured the Elastic Beanstalk environment. We've set the inbound rules for the RDS security group. And we're going to worry about Travis in just a minute. So we're going to first test out that it actually works all together. So in order to do this, we actually need to bundle up and deploy our Elastic Beanstalk app. So to do that, first we're going to need to install from npm. And what we do is essentially, like right now what we're going to do is we're going to tell Elastic Beanstalk specifically to take our app, bundle it up, and deploy it. Eventually what we'll do is we'll hook it up to Travis CI, and so then we can push to our master branch to do MVC++, and then Travis will build it, and when it succeeds, then it will say, hey, Elastic Beanstalk, deploy this build, this version of the app. So we're just doing a simple proof of concept right now to make sure that everything is hooked up correctly. Because as I've found, having attempted this 3 times now and each one going wrong in some different way, there's always something that can go wrong. So hopefully it all works this time. To actually build out the static assets, the specific command for this app is to type in grunt collect static. In my case, I don't have grunt globally installed, so I'm just going to go ahead and use the node modules version. So that's .bin/grunt, and then collect static. and we can see here that the static asset directory has been initialized at public. So we can see that here, and that has all of our static assets. So once we do that, then we can, once we're ready for like a new version that we're happy with, we can say eb deploy, and this will take our app, zip it up, send it up to S3, and then tell our EC2 instances to download that version and sort of like unbundle it and build everything. And Elastic Beanstalk has a bunch of configuration and logic around what it does to do that, to sort of like set everything up and sort of deploy a new version. But it's pretty intelligent as far as like its defaults go. But there's a lot more config that you can do. Okay, so we have finished deploying the new version. And we can also take a look at our Elastic Beanstalk. It seems that everything's okay. A new application version has been deployed. We can see this in the events. And the Elastic Beanstalk environment provides us with this URL. So we can see like this is the CNAME prefix that we were talking about here. We can go ahead and open that. And yes, indeed, it does appear to be working. So if I say hello world, and then I refresh the page, it's still there. Yay. We're so cool. So we can say that we've done those two things. So the last thing that we need to do is set up Travis CI. So let's get started with that. To do that, we're going to go ahead and open up the README. So first we're going to sign into Travis and tell it about our repo. I'm going to go travisci.org. .com is the one for private repos. .org is the free one for public repos. I'm going to click on Add, and I'm going to find to do MVC. I'm going to turn that on. And then I'm going to take a look at the environment variables. And here we have our node env is for test. So I think that's everything that we need. Yeah, that's, if this isn't set up already, you need to put that in there. Node env is test because we have a specific test environment that creates this to-dos test database, or that uses this to-dos test database. So you need to make sure that that's in there. I think that that's actually there from a previous time when I set this up, because obviously I tested this beforehand. So I think that you'll need to manually enter this part in. Okay, so once that's all set, then you can take a look at the builds. There's no builds right now. So we have Travis knowing about our repo, and the way that Travis works is that it expects you to have a travis.yaml file. So I'm going to go ahead and create that. .travis.yaml. Save that. And we're going to copy this code in here. Okay, so I'm just going to walk through some of this. So we set the language to be Node. We can specify the version. In our case, it expects version 6, but you can choose Node. So you could say Node. That would grab you the latest node, or you can look up the docs and find what version you want. This allows us to cache our node modules, so for faster builds. I don't remember what this does, but I've seen it in a lot of my Travis YAML files, so I just keep it there. I should probably look it up. This sets up Travis to allow us to use PostgreSQL. To do the installation, we tell it to run npm install. That'll install all of our packages for us. The before script is essentially anything that we need to run before we actually run our tests. In our case, we need to set up the database using a couple commands. So these commands this is what you use. So you essentially tell PostgreSQL to use this command, create database, to-dos test. There's more details on Travis documentation about passing commands to PostgreSQL, but this is the basic thing. And then we use, or this, excuse me, this repo uses Sequelize to manage its SQL database. So we have to run a migration on it. So we say Sequelize db migrate. And then for the scripts, like what the actual meat of the build, we run npm test. And then if that succeeds, then we build the static artifacts just as we did before. So that's this guy here. So that's pretty good, except this won't actually deploy our application. This will run our build, and it'll tell us that it succeeded, which is very useful. But we also want to deploy to Elastic Beanstalk when it succeeds. So to do that, we're going to go ahead and set up Travis to do that. We will want to have the Travis CLI installed. So there's some instructions here on setting that up. And we don't actually need the secret access key because it'll provide it for us. But anyway, we'll have access to this Travis command, and then we'll just say Travis setup Elastic Beanstalk. And so it's asking us, we've detected this repository, that's correct. We're going to provide our AWS access key. So that's this guy, and our secret access key, which is this guy. And this is super important. You want to specify the correct region that the Elastic Beanstalk environment is in. The app is in? No, the environment. Because it matters. If you have resources in different regions, then they don't necessarily show up. So like if I go to EC2, I have all of these security groups, but that's for Oregon. If I go over to US East 1, you'll see that I don't have any security groups. So as a side note, if you are looking for your resources and you can't find them, just make sure that you're on the correct region, because it doesn't happen often, but sometimes your region gets changed somehow and you just happen to not be looking at the correct one. So we have to specify that it's in US West 2, and our application name was to-dos, oh goodness, I've already forgotten it, to-do MVC++. And the environment name is to-do MVC++ prod. And we do want to encrypt the secret access key. And the reason for that is we're going to save this Travis YAML file up into our GitHub repo. And so we want to make sure that somebody who happens to look at our repo is not able to access our AWS account through those credentials. And also, yeah, we want to only deploy from this repo. I don't exactly know what that does, but it seems reasonable. As one other side note, when you set it up this way, what you're telling Travis to do is to use your credentials to be able to deploy to Elastic Beanstalk. So if you happen to have a team of a lot of devs, you might actually want to set up a user called Travis Deploy, or something similarly named, and give it specific access that it needs to be able to make the deployment, perhaps only being able to talk to Elastic Beanstalk. And then this way, we know that key is being used, that user is being used by Travis to deploy things. In my case, I don't really worry about that, or I'm not really worried about that right now. But yeah, it's easy to set that up because you've already done it once. So I think that's everything we need. I'm going to go ahead and just take a look at this. All right. So what this does for Travis, the Travis YAML file, is that it adds these extra lines to it. So it adds this deploy bit, and it tells us that we're using Elastic Beanstalk, and here's our access key, and then this is our special super dandy encrypted key, and the region, and the app, and env name. But we also need to provide one other thing, and it's a little bit weird that it doesn't provide it here. I've never quite understood why. But we need to specify a bucket name, and then a bucket path, I believe. Is that correct? I need to just write one thing down, and I made a note of this, and I just want to make sure I don't get it wrong. Yeah, bucket name and bucket path. So the bucket name you're going to get from S3. So what we're saying is, hey Travis, I want you to upload it to this bucket that Elastic Beanstalk is using. So we're going to take a look at S3. And we can see here that Elastic Beanstalk did indeed create a bucket for us. So we're going to copy this bucket name. Wow, they do not allow you. There we go. So we're going to put that here. And then the bucket, if we did just that, then it would save these build artifacts into just this root directory here, which I don't particularly like. I want to put it into the one specifically for my, my application. So I'm going to also grab the path, which is this guy. Why do you make that impossible to copy? That's really stupid. Come on, S3. Okay, anyway, to-dos, MVC++. I'll just to-do MVC++. Okay, and then we also want to tell Travis to not clean up our build artifacts before we deploy. So we say skip cleanup is true, and that's this line down here. And essentially what that does is, like, because we're running this line here to grunt collect static, we don't want to have those static assets cleaned up before we actually bundle everything up to deploy it. So we just say skip cleanup is true. So I think that that's just about everything we need. So I'm going to go ahead and save it. And to make sure that we're actually doing everything correctly, I'm going to make a change to the view. That's under source, rather. That's in the server, and we have views, and we have index. So this is called to-dos, and so I'm going to say to-dos by Andrew. And that's going to be my change. So I'm going to go ahead and just check everything. We've changed our views. We've added our Travis file. That all looks good. So we're setting up Travis and changing view to test deployment process. Got that. And we're going to push that up. Cool. Once we've done that, we'll go back over to our to-do MVC++ repo. And it's looking at some old builds that I had done for this previously. Let's go ahead and refresh the page. And for some reason it's not building. There we go. I'm just going to go ahead and pause this for a minute and do a little bit of debugging. Okay, so there was nothing actually wrong with it. I was just being impatient. So the build has run through. It took about a minute and a half, so I also just kept it paused for during that time. Just to walk through it, this is, installing a bunch of stuff. Here we're installing more things. This is the pre-script, before script. So we're creating the database, we're migrating the database. We can see the different pieces being added. And then we run our tests. Everything works. The to-do model, which does talk to Postgres. So like we're testing that everything's set up correctly. It finished, so then we run our grunt collect static. That completes. And then we're going to go ahead and deploy. We can see it deploying to Elastic Beanstalk. And then if you walk over to here, we can see that it's the environment was updated. We deployed a new application version that's getting deployed to the EC2 instances and then gets transitioned. And if we go back over to Vue.js and we reload it, it's looking crappy because this was not a good CSS, but we can see that it should say to-dos by Andrew on there. So it worked. We have a running application on Elastic Beanstalk that is using Travis continuous integration to manage its deployments. And there you have it, folks. We have our basics of AWS DevOps for Dummies. I hope you've enjoyed this. If you want to, you can always check out more about me at andrewsouthpaw.com. So this is a collection of articles that I write and stuff that I'm interested in. You can always check me out on GitHub as well. So my handle there is Andrew Southpaw. And you can also find me on LinkedIn by the same name, Andrew Southpaw. So I hope you've enjoyed it. Please feel free to send me any feedback that you have. You can reach me at andrewsmith@alumni.stanford.edu. My email is on my GitHub. And yeah, I would just love to hear any thoughts that you had or stuff that worked or stuff that you'd like to learn about next. All right, take care.